Okay, that's what you guys are doing today. Okay. Getting to know you. What's your favorite day of the week and why? So you guys can answer the question when I ask. Okay. And then I want you to take a moment here, look at the picture, and tell me, what do you think is going on in the picture? What's happening here? Why do you say that? Okay, why do you say that? All right, and I want you to use details from the picture to justify your answer. Okay. You can pause the video, you can stop the video, okay, and hopefully there's a translation at the bottom. And I'm going to show you a little demolition derby video. And then we're going to do this problem. In 67 CE, Josephus and 40 fellow soldiers were surrounded by a group of Roman soldiers who were intent on capturing them. Fearing capture, they decided that they would kill themselves instead. And while Josephus did not agree with this proposal, he was afraid to disagree. Instead, he suggested that they arrange themselves in a circle, and counting around the circle in a clockwise direction, every second man should be killed until there was only one survivor, who would then kill himself. Josephus wanted to be that man, so he can survive, and he therefore had to figure out which position to stand in. So, so imagine there was 5 soldiers. Soldier 1, Soldier 2, Soldier 3, Soldier 4, Soldier 5. So according to this, 1 will kill 2, 3 will kill 4, 5 will kill 1, and 3 will kill 5. So who's left? Number 3. Let's say there was 8 soldiers. 1, 2, 3, 4, 5, 6, 7, 8. 1 will kill 2, 3 will kill 4, 5 will kill 6, 7 will kill 8, 1 will kill 3, 5 will kill 7, and 1 will kill 5. So if there's 8 soldiers, you want to be number 1 because he's going to be the last one. So the question says, what happens when there are Josephus and 40 soldiers? So there's going to be 1, 2, 3, 4, all the way to 41. Who do you want to be the last one? So that's the first question. The second question I'm going to ask you is, what if there were 1, 2, 3, 4, 488 soldiers? Where do you want to be? Who do you want to be? What if you had 1, 2, 3, 4, 5, 999 soldiers? Who do you want to be? Well, I'm hoping you can find a pattern or see what's going on here to determine where you would want to be. Okay, so you're going to do a few of these examples, or you're going to try a few, collect as much data as you can, and see if you can find a pattern. Okay, and you're going to answer the question. In what position should Josephus stand in the circle to be the last man standing? And then find a formula or expression we can use for n number of soldiers in the circle. So no matter how many soldiers, you should be able to tell me which position to be in. Okay, so that's going to be your whiteboard problem. All right, so in the previous class, we did mean, median, mode, and range. Actually, we didn't do range, so we'll do it today. Mean. To find the mean, we have to do 45 plus 78 plus 82 plus 85 plus 88. And then we're going to divide that by 1, 2, 3, 4, 5. So if you do that, and you're going to take your calculator, right? And you're going to add 45 plus 78 plus 82 plus 85 plus 88. That's going to equal to 378. And then you're going to divide by 5. So the mean is 75.6. To find the median, we have to put the numbers in order. So 45, 78, 82, and they're already in order, 85, 88. So which number is in the middle? Well, work yourself towards the middle, this and this, this and this, and then 82 is the middle number. So median is 82. Mode is the number that shows up the most. If if you look at the numbers here, there's nothing that repeats. So in this case, there is no number that shows up more than the other number. So there is no mode. What's the range? So now we didn't talk about range last time, but range is simply the highest minus the lowest. The highest number is 88, the lowest number is 45, so the range is 43. So the range tells us how spread apart our data is. Okay? One second. So the next screen, I want you to look at this following data. Class 1 took a test and Class 2 took a test. So I'm going to ask you, which class do you think did better on the test? Well, did Class 1 did better or did Class 2 did better? Overall, which class did better? So if you look at it, I want you to decide which one did better. Now, what did you use to find who did better? Did you do the mean? Did you do the median? Or did you do the mode? Which of the three did you use to determine who is the better class? Now, if you use the mean, you're going to add 100 plus 100 plus 100 plus 100 plus 90 plus 60 plus 60 plus 60 plus 50 plus 50. So let's write class 1 over here and class 2. So if you do the mean, you get 100. So let's add all those numbers. 100 plus 100 plus 100 plus 100 plus 90 plus 60 plus 60 plus 60 plus 50 plus 50. Enter, and you get 770 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. So the mean is 77. For the second class, 100 plus 90 plus 90 plus 85 plus 80 plus 75 plus 70 plus 70 plus 60 plus 50. You get, again, 770 divided by 10 equals 77. So the mean is the same for both classes. Now, if you do the median, this one and this one, 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 and you have two numbers in the median and the middle, so 90 plus 60, right, is 150. Divide by 2, you get 75. So the median for class 1 is 75. For class 2, right, again, you cross out and you work towards the middle. 4. Then you have two numbers in the middle. The median is 77.5. Now, is there a mode? Well, if you look at class 1, what's the mode? What's the number that shows up the most? The mode is 100, right? Because 100 showed up first time, so 4 times. So the mode is 100. The mode here for class 2 is 70 came out twice and 90. So there's 70 and 90. So now, who do you think, which of these three best describes the data that you see? So class 1 is, do you think the mean, the median, or the mode? Well, do you think class 1, the mode represents, which is 100, does 100 represents everybody? Does 75 represent most of the kids in the class, or does 77 represent the class? So I'm going to say that it's the mean, right? Remember, do you see any outliers here? Right, there's not really an outlier. So when there is no outlier, who do you want to use? You want to use the mean. So the mean of class 1 is 77. The mean of class 2 is 77. But do you really think they did the same? They did better. They performed the same class 1 and class 2. Well, let me show you a different side. This is the same data. This is class 1, and then this is class 2. Same exact numbers. Now, who do you think did better, class 1 or class 2? I think overall, class 2, right, was more consistent, right? You have more kids scoring somewhere here in the middle, whereas in class 1, they either failed the test or passed the test, right? So according to this, I think class 2 did better than class 1. So the thing we're going to do today is called mean absolute deviation. So to do the mean absolute deviation, right, we're going to need the mean. And that is going to tell us how spread apart the data is. So if you look at class 1, look, the mean is 77 right here. Let me put 77. And then over here, it's also 77. But notice that in class 1, the grades are kind of far away from 77, and in class 2, the student scores are all closer to the mean. So it's telling you that there's less variability, there's less change in class 2 than in class 1. In class 1, there's a lot of change. There's 2 spread apart. And in class 2, they are closer together. So that's what we're going to find today. How close is the data to the mean, or how far apart is the data from the mean? Okay, so class 1 is 77. So first you find the mean. Then you're going to subtract each of these values, right? You're going to subtract 77 from each of these values. So you're going to do this. Minus 77, minus 77, minus 77. So if you do that, here you get 23, here you get 23, 23, 23, 13. Here you get negative 17, but we're going to use the absolute value, so you actually have 17. Here you get negative 17 again, but you're going to take the absolute value, so it's going to be 17. Same thing here. Again, you get negative 17, but we use the absolute value. Negative 27, we use the absolute value. And then negative 27, we use the absolute value. So these are the distances these numbers are away from 77. So after you do that, you find the mean again, the MAD. And to find the MAD, right, mean absolute deviation, we're going to add all these numbers. We're going to go 23 plus 23 plus 23 plus 23 plus 13 plus 17 plus 17 plus 17 plus 27 plus 27. And we're going to add all that and divide by 10. And we're going to get, and that's going to tell us what the MAD is. So 23 plus 23 plus 23 plus 23 plus 13 plus 17 plus 17 plus 17 plus 27 plus 27 is going to give us 210. Divided by 10 is 21. So the MAD, the mean absolute deviation, is 21. So that's telling us that in average, right, these points, right, these numbers are 21 units away from 77. So they're not too close, right? They're not too close. So what it's telling you that these guys here and these guys here are in average 21 units away. Now, look at the second one. Do you think the MAD is going to be higher or the MAD is going to be lower? Right? They're closer to 77, so that distance, I think it's going to be lower. So the mean again is 770 divided by 10, which is 77. So we're going to repeat the process. Minus 77, minus 77. Okay, minus 77. Okay, so let's subtract. This is 23. This is 17. Sorry, this is 13. This is 13. This is 8. this is 3, this is 2, this is 7, this is 17, this is 17, and this is 27. So what do we do with these numbers? We add them, right? So we're going to add. So we're going to find the MAD, mean absolute deviation. We're going to add all that and divide by 10. So 23 plus 13 plus 13 plus 8 plus 3 plus 2 plus 7 plus 17 plus 17 plus 27 equals 130. And if you divide it by 10, look, the MAD is only 13. Notice that this MAD is 13 is lower than this one. Why is it lower? Because look, the numbers are closer to the mean. All these, the points here are closer to 77 than these numbers are. So obviously, the MAD is going to be lower. So when the MAD is lower, it means that the numbers are closer, right? Closer to the mean. Closer to the mean. Okay. I'm not going to do this example with the class, but we can do this one. So mean absolute deviation, or MAD, M-A-D, is a number used to describe the spread of a data set. It's how far the data spread out. It can also be called measure of spread. One measure of variability is the mean absolute deviation. Okay, it's the average or mean of the distances between the data values and the mean of the data set. So look at this. We have Mr. Smith. He plays basketball. He plays basketball. In 2013, he played 5 games, and he scored 15, 17, 14, 21, and 18. In 2014, he scored 20, 9, 34, 2, 35. So which of those 2 years was he more consistent, less variability? So let's do a dot plot. So let's do a dot plot for 2013. We need, let's say, 14, 15, 16, 17, 18, 19, 20, 21. So we have 121, 118, 114, 117, and 115. Let's find the mean. So if you add those numbers, 15 plus 17 plus 14 plus 21 plus 18, enter, we get that the mean is 85 divided by 5. The mean is 17. So I'll put a little arrow here, change colors. Right here, I'm going to call that this is the mean. Now, we have to find the MAD here, right? So do you think the MAD is going to be a high MAD or a low MAD? Are these numbers close to the mean, or are they far away from the mean? So we're going to, let me use the numbers again here. We're going to do, here are my numbers, 15, 14, sorry, let me do it in order. 15, 17, 14, 21, and 18. So if you do minus 17, minus 17, minus 17, minus 17, minus 17, here we get negative 2, which is take the absolute value. It's going to be 2. Here it's going to be 0. Here it's going to be negative 3. Take the absolute value is 3. Here it's going to be 3. And here it's going to be 1. So we're going to add, to find the MAD, we're going to do 2 plus 0 plus 3 plus 3 plus 1. Then divide that by 5. So 2 plus 0 plus 3 plus 3 plus 1, enter, equals 9. Divide that by 5, and the MAD is 1.8. See how what do you call, small that number is? Because these numbers are very, very close to the mean, right? Let me write that the MAD here is 1.8. Let me erase. And do the MAD for 2014. So let's do the mean. So actually, you know what? Sorry. Let me do a little graph. So 5, 10, 15, 20, 25, 30, 35. So we have a 20. We have a 9. We have a 34. we have a 2, and we have a 35. Let's add them up. So the mean, if we add them up, is 20 plus 9 plus 34 plus 2 plus 35. Enter, we get 100. If we divide that by 5, the mean is 20. So remember what we have to do later. We got to put these like this, right? And then we have to subtract 20. So, right, this is 35. So we're going to do minus 20, minus 20, minus 20, minus 20, minus 20. That's a 0. This is negative 11 or 11 because it's take the absolute value. This is 14. This is negative 18 or 18. And this is 15, right? So now we find the MAD. We're going to do 0 plus 11 plus 14 plus 18 plus 15. And divide that by 5. So we get 0 plus 11 plus 14 plus 18 plus 15. We get 58. Divide by 5. And we get 11.6. So see how the MAD is much bigger? So the MAD for class for 2014 is 11.6. What does that mean? Well, a low MAD means that he's more consistent, right? The data is not as spread out. A bigger MAD means like the data, and you can tell from the picture, right, from the graph, that, so where's the mean, by the way? The mean was 20, so I'll put a line here. Mean. Are they close to the mean? Is 2 close to the mean? Is 7 close to the mean? Sorry, 9 close to the mean? Is 34 close to the mean? They're pretty spread out, right? So that's why the MAD for 2014 is bigger than the MAD for 2013. All right, so again, during which year was Mr. Smith more consistent? Well, in 2013, he was more consistent, right? There was less variability. Okay. What does a low MAD mean? A low MAD means that the data is closer to the mean. What does a high MAD tell you about the data? It means that the data is more spread out or further away from the mean. All right, so I'm going to be working that with the class, so I'd like you to do this one. Okay, and then you'll do a check for understanding as well. Okay, and at this point, so you guys, I want you to do this in your notebook. Let's find the mean. So the mean, we're going to add these numbers, right? 45 plus 47 plus 58 plus, and we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a 9 over here. 45 plus 47 plus 56 plus 48 plus 45 plus 47 plus 56 plus 48 plus 46 plus 52 plus 57 plus 52 plus 45. Enter. We get 448. Divided by 9, it's 49, and I'm going to round it to the nearest hundreds, 49.78. So the mean is 49.78. Now to find the MAD, I'm going to do minus 49.78, 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 78, and minus 49.78. So, what's 45 minus 49.78? Absolute value, it's going to be 4.78 plus 2.78 plus 6.22 plus 1.78 plus 3.78 plus 2.22 plus 7.22 plus 2.22 and then plus 4.78. So we're going to add all that and we're going to divide that by 9. So 4.78 plus 2.78 plus 6.22 plus 1.78 plus 3.78 plus 2.22 plus 7.22 plus 2.22 plus 4.78, and that's going to give us 35.78 divided by 9 equals 3.98. So the math's not that bad, right? It's only, they're really close. So if you think about it, what was the mean? The mean was 49.78. Are these numbers close? Is 49 close to 49.78? Is 48 close to 49.78? They're pretty close, right? So that's why your MAD here is not that big. Okay, it's a low MAD because the numbers are close to the mean. Your check for understanding is going to be the same thing, right? So I actually want you to do this by yourself. So you're going to find the mean, right? And then you're going to do the MAD. There's two things I'd like you to do. All right, so that's your lesson. Hopefully this helped a little bit.